All right, welcome to another exciting episode of Advanced Level Chemistry here at Spain Park High School. Today is Monday, February the 10th. All right, and so we are in the midst of learning how to write formulas and name ionic compounds. So when we're looking up here, okay, we're to name the following and write the formula. So if you're watching this at home or somewhere across the world and you want to participate in this, pause this video right now and see if you can name the following and write the formulas from what you learned from the video on Friday. But for us, we're going to go on and look. First off, when we look at these two compounds, what type of compound are they? Are they ionic? Are they covalent? Or are they metallic? What are they?
Ionic.
How do you know that, Ed?
There's a metal and a non-metal.
A metal. I can look at this very first thing, and if it's a metal, I know it's ionic. Because we're going to have to identify, the first thing, we're going to learn about naming covalent compounds today. We're going to learn about naming acids today. And so we're going to have to be able to identify, is it an acid, is it covalent, or is it ionic? And the first thing in the formula, the first thing in the name is going to tell us which one it is. If the first thing's a metal, it's ionic. If the first thing's a non-metal, it's going to be covalent. Anybody know about an acid? What's the first thing going to be? What element or ion is all present in all acids? I said at the very beginning of this unit. H plus. Okay, and we'll deal with that later. Okay, so I know it's ionic, so I'm in my ionic rules. So we learned on Friday, how do we name an ionic compound? What goes first? The metal, the positive. Okay, well first off, we're always going to have just two things. So you have to identify your two things. That's my positive thing. This whole thing is my negative thing. Okay, this is my positive thing. There's only a positive thing and a negative. You're not going to have two negatives, three negative things. No matter how complicated the negative thing is, it's just one whole thing. We're just going to recognize and know that name. That's the sheet that I gave you on Friday. We have the chart up here. All of that tells us we're going to be able to figure out the polyatomic ion, what the name is. Okay, so K is, what's the name of K?
Potassium.
Potassium. So I know it's going to be potassium. Okay? So that's my positive. Oh, so I have to ask myself, though, does potassium have more than one possible oxidation state? How do we know the answer to that question? Okay, the number one thing is in the first column. And if you look on your periodic table that I gave you that matches this one, you'll know, first off, everything in column one, the alkali metals, all only have one possible oxidation state. What is that possible oxidation state? Plus one. Alkaline earth metals, the second column, all have what possible oxidation state? Plus two. But if you can't remember that, you'll always have this. The oxidation state's given. It's the little black number right above the symbol. Okay? And all of these have a 1, a plus 1, and they only have one possible oxidation state. There's only one number. Compare that with these transition metals like manganese that has 2, 3, 4, 6, 7. It's got 5 different possible positive oxidation states. Okay? So it's only when there's more than one oxidation state do you need to use a Roman numeral. Since it only has one, no Roman numeral is necessary. So I'm just going to say potassium. Then I'm going to go and I'm going to look at the next one. The negative thing, MnO4. Call it MnO4, I have no idea. So what do? You come up here and you look on the chart. What's the name of MnO4? Permanganate. You just write the name of the ion. Name the positive ion first. Name the negative ion last. No prefixes. We don't have to say anything. We just say potassium permanganate. Potassium permanganate. Now, we do the same thing here. Is this ionic compound, and how do I know? Yes, because nickel's a metal. So it's going to be nickel, but then you have to go look. Does nickel have more than one possible oxidation state?
Yes.
How do you know?
On
On the periodic table, what are the possibilities? Plus 2 and plus 3. Now, there's going to be two ways to do this, a fail-safe and then a shortcut. That works most of the time. So I need to know what the charge is then on nickel. So I have to go to nitrate. This is my positive, that's my negative. So I go on my chart, what's the charge on nitrate? Okay, does everybody see that? Nitrate, it's right down here at the bottom. -1. Now look, that -1 is not on the oxygen. The -1's on the whole thing. How many of the whole things do I have? 2 of them. So what's the total negative? -2. And what does the sum have to add up to? 0. So what must nickels be? +2. So you will have to be able to do this on the, for the test. You have to be able to calculate oxidation. That's why we did that first on Friday. Okay, so it's +2. So what's the name gonna be? Nickel.
Nitrate.
And then Roman numeral 2, and if you want, you can do that for Roman numeral 2, nitrate. We don't have to do anything with this 2 here. Now the shortcut is, generally speaking, whatever that subscript is here, because when we do this, we're gonna crisscross. This is the reverse crisscross. This 2 is gonna come down here. Generally, whatever that subscript is the charge on the metal up here. Okay, just a little shortcut for you. Doesn't work all the time, but it works most of the time. This works all the time. So I want to go the other way now. Now I want a name. I did the same thing again. I did this in first period. Write the formulas for these. Oh, I know. Like, of course, nobody said anything, but I mean, I'm getting old, y'all. The bread's beginning to mold. I'm sorry. Okay, so let me try some other ones then, okay? And so we'll try, okay, let's go with sodium oxide, okay? And we'll just say iron 3. We'll just make this one nice and fun, sulfate. Okay? Now, we don't have time, if I want to finish all these notes, we don't have time for me to give you the practice on these. Okay? But let's just kind of think about them. When I want to write the formulas, if you look at your rules, you write just the symbol in charge. What's the symbol in charge of sodium? Na. What's the charge? +1. No, you can just say plus. Okay, if you just say plus, it's +1. Or you can write +1 if you want to. Okay, and what about oxide? What's the symbol in charge of oxide?
That's -2.
Okay, but what's the symbol?
O.
Just O, and that's right. It's going to be -2 or 2 minus, however you want to write it. It really doesn't matter. 2 minus is the correct thing in this since it's ionic. So what's the formula need to be?
Na2O.
Okay? Okay, because we need to make the positive equal the negative. We're going to crisscross. We're going to cross multiply. But hopefully you can just do this without really doing it. So you're just going to see, I need 2 of the pluses to balance out the 2. So now it's +2 minus 2 is going to equal 0. Okay, but I'm just crisscrossing. I'm going to cross multiply. Write the formulas for it. Okay? Does everybody see that? Does anybody have any questions on where the numbers are coming from? All right, so now I say iron 3 sulfate. Well, what does the Roman numeral tell me about iron? No, doesn't tell me that there's 3 of them. The charge is +3. So I'm going to write Fe and then 3 plus. Okay, that's what the Roman numeral. The Roman numeral is telling me, and let's just get a little graphic here. The Roman numeral 3 is telling me that. Okay? And what's what's sulfate? SO4. And it's 2 minus. Okay? So now I have to crisscross. So, what subscript goes here? 2. But where do I put the 3? Say that again? Outside the parentheses, which means I need parentheses. to get it, okay? So you gotta have the 3 here, because I need 3 sulfates, okay? Now, notice I don't need a parenthesis on the iron, because it's just a monatomic ion. But when you have a polyatomic ion, we need more than one, you put a parenthesis with the 3 down below it, okay? Now, I don't care if the -2 is inside the parenthesis, outside the parenthesis. Notice how I kind of wrote the parenthesis right through the middle of it, because the charges don't really need to be there. This is really a rough draft, but this is the way I really kind of want to see it, because that way I can know what you did right, or if you messed up, we can figure out what you did as far as charges and how you got the wrong subscripts. Okay, but technically it would be rewritten Fe2 SO4 3 with no charges written. Okay, but we need the charges to know how to crisscross, so it's 100% fine with me for you to leave it like that. Okay?
Oh, how did you know that there's 2 irons?
Because I'm having to balance, I have a +3 and a -2, so what's my lowest common multiple for those two? 6, so I gotta make the positive equal to negative. So that's why I'm crisscrossing, I'm cross-multiplying to get the lowest common multiple. So now this is +6, and this is gonna be -6, so it's gonna add up to 0. Okay, so this 2 came here, that 3 went there. Okay? All right, we're gonna have lots more practice of those tomorrow and Wednesday. Okay? So now let's look at the next one. Now the next one I can teach you in 5 minutes. You're gonna wish that the test is all this next type. Okay? Because the next type is going to be writing formulas for covalent compounds. Covalent compounds. Again, how are we going to tell if it's covalent or not? 2 nonmetals. All right, starting here with a clean slate, ready to go. Binary molecular compounds. Okay? First off, we're going to know it's covalent because it's going to be 2 nonmetals. Okay? 2 nonmetals. It's going to be important that we just recognize that. Now, we're always got, which one always goes first? The first one. Yeah, but which one are we got? Positive or negative? It's going to go first. Always the positive. Name the positive element. Positive is always going to be first. Using a prefix to indicate the number of atoms in the molecule if there is more, is it is or more, is or are? If there is more than 1. Okay. Name never starts with mono. Name never starts with mono. Okay? And then we're going to name the negative ion last. Negative element. And it's not ion, it's a negative element. With the appropriate prefix. Now notice this one, including mono here. We don't use mono on the first, but we do use mono on the second if there's only one of the second. And when we turn the page, we'll have an example of this. Using the root word of the element and an "-ide" suffix. Now every single one of these is going to end in "-ide". Makes it simple. It's always going to be "-ide". We don't have any "-ides" or "-eights" on this one. Only "-ides". Again, that's pretty much all the notes for this one. This is much simpler. But what are the prefixes? What's 1? We already said. Mono. Now what's 2? Di. All right? Now, look up here on this chart. Okay? Type of follow me. A lot of times bi is used as a prefix for two. A bicycle has two wheels, okay? But in chemistry, bi is going to mean hydrogen. You may have heard of sodium bicarbonate, baking soda. Well, it's really sodium hydrogen carbonate. Somehow, I don't know where the origin of this came from. Bi means hydrogen. So if we have bicarbonate, it's hydrogen carbonate. Now notice, what's the charge always on hydrogen? What's the charge on hydrogen? Plus one. So if I put a plus one on a minus two, it's going to end up being a minus one. So hydrogen carbonate, bicarbonate, is going to be HCO3, just minus one. Okay? So I look out down here, I have bisulfate. Well, sulfate's minus two. So bisulfate is minus one. That's hydrogen sulfate. So the official name is hydrogen sulfate. That's the one you're going to use. Bisulfate is an old school, but it's very, very common still. So you just need to know anytime you have sodium bicarbonate, anything bicarbonate, bisulfate, bisulfide, that's really a hydrogen sulfide. Okay? So it's just, and then the hydrogen is always plus one, so it makes the charge come down one. Now there is kind of a crazy one here, because phosphate's minus three, you can actually add two hydrogens, and so we have monohydrogen phosphate, dihydrogen phosphate, meaning that you've added one hydrogen, two hydrogens, and it's still an ion. So even though there's a prefix in it, that's actually the name of the ion. Okay, that's the only one you're ever going to have prefix in here on that. So we're always going to use di, not bi, because bi is going to mean hydrogen. So what's three? Tri. And then four from our shapes. What did we learn four was? Tetra. And then now we just go Latin. 5 is penta. 6 is hexa. And staying with the H's, 7 is going to be hepta. 8, octa. 9, nona. And then 10 is deca. So all we have to have are these prefixes, then we can name everything and write formulas for everything. Okay? Yeah, we only have a little bit left to go. Okay? That's the way I am when somebody's doing a PowerPoint presentation. I'm always looking, how many more slides are there until you get to the end? Okay, so I don't like to do PowerPoint because, you know, we never know. Okay, so does everybody have this so we can just look at examples? Everybody? And I think most of y'all know these prefixes already just from math and stuff. Okay, so I look at the examples. Close enough. I look at the examples. Okay, so first off, how do I know this is covalent? Two nonmetals. Okay, look at the first thing is to the right of the zigzag line. Okay, so two nonmetals. So now I know I can use prefixes. Ionic, I can't use prefixes.
Isn't that the sand?
That is the sand. So what's special about this covalent compound? It's a covalent network, but we name it the same. If it's covalent, we're going to use the same rules whether it's network or molecular. Okay? So, how many silicons do I have? One. Do I need a prefix? No, I'm just going to say silicon. It's just the name of the first element. And then, how many oxygens do I have? 2. So it's going to be what? Di, but it's always going to end in I, so dioxide. Silicon dioxide. Notice the next one. How many nitrogens do I have? 2. So it's going to be dinitrogen. You do use prefixes if there's more than one. Dinitrogen, and then how many hydrogens do I have? So it's going to be tetrahydride. Still going to end in IDE. Okay? So what would N2O3 be? Dinitrogen trioxide. Yes, sir.
Why don't we put the hydrogen reverse if the hydrogen has a positive charge?
You just write it the way it's written. For some reason with nitrogen and hydrogen, like in ammonia, whatever, nitrogen comes first. I really don't know why they always do it that way, but they do. But that's a good observation that the hydrogen is going to be the positive oxidation state. But for nitrogen and hydrogen, nitrogen always comes first. And that's a good question. I think that's just kind of happened in old school and they've never changed it. Okay, so you might want to write, if you want to just put this in your notes, if you didn't write it down, N2O3 is, what did we say it was? Dinitrogen trihydride. You don't do anything to the first element, you just name it with a prefix. Okay, so turn the page. Oh, I just wrote on the wall. Okay, so now, if we want to go the other way, the name of the binary molecular molecule contains, this is redundant right here, we already know this, prefixes, okay, indicating the number of atoms of each element that are present. If no prefix is indicated, what do we assume? One. Okay, and that's really just going to be on the first one. Now this one is what always helps me to know whether I, do I use mono or do I not? Because this is a very common compound. Carbon monoxide. What's the formula going to be? CO. Okay. What do you know about carbon monoxide? It's poisonous. Why is it poisonous? Does anyone know? Okay, it is odorless and odorless and colorless, and so you can't hardly know it's there. But the reason why it's so dangerous is because, well, first off, how does oxygen get to your cells from the lungs?
It's absorbed through the bronchi.
Okay, well, absorbed through the bronchi, but how does it get carried? In the blood, but what part of the blood? The powerhouse of the cell. That's all I know about biology. No. Begins with an H.
Hydrogen.
There you go. It's the hemoglobin. Okay, remember? So you did learn that. Okay, so the oxygen attaches to the hemoglobin in the lungs. Okay, and the pulmonary artery pumps the blood to the lungs. Okay, and then it goes from there, and I don't know the rest of the anatomy, but it goes to the cells via the arteries. Okay, you got to help me out there, all you anatomy people. Okay, but the oxygen forms this complex, but when it gets to the cells, there's a chemical reaction taking place. There is an equilibrium, and the hemoglobin releases the oxygen into the cell, and then it picks up the carbon dioxide and takes it back to the lungs where we exhale it. The problem with carbon monoxide is that it forms a more stable complex with the hemoglobin than the oxygen does. It does, and so then when you breathe in the carbon monoxide, it sticks to the hemoglobin, but then it doesn't release. And it ties up your hemoglobin, and then it's supposedly if 20%, I read this somewhere a long time ago, 20% of your hemoglobin gets tied up with carbon monoxide, you basically suffocate even though you're breathing oxygen. The oxygen's not getting to your cells because the hemoglobin's tied up with the carbon monoxide. Now, if you happen to smoke cigarettes, cigarettes have some carbon monoxide when you inhale. Supposedly, with someone that smokes on a regular basis, about 10% of their hemoglobins are always occupied with carbon monoxide, which means they're walking around half dead. About 10%. That's why they're having trouble breathing. That's why they breathe heavy, because all the oxygen, their lungs aren't working efficiently because it's not their lungs, it's the blood carrying the oxygen to their cells. The hemoglobins are all tied up. So they're much more susceptible to carbon monoxide poisoning. Yes, sir.
Is it like fatal?
Oh yeah, I mean, well, cigarette smoking is fatal over time because of lung cancer. My sister died of esophageal cancer because of her smoking.
I mean, like, does like the carbon monoxide go away? Like,
Yeah, over time, it finally does release if you quit smoking. Yeah, but again, and we'll talk more about it when next unit when we're doing this. We'll talk more about the carbon monoxide and the issues. But So, but the main thing on this, on the carbon monoxide, is just notice that we use the mono on the second one, you don't use the mono on the first one. So this very common compound is going to be what? CO2. So what is diarsenic pentoxide going to be? As2. Arsenic is As2O5. That's all there is to it. You don't have to worry about crisscrossing, balancing oxidation numbers, nothing, just whatever the prefix is, that's what you write. If it's covalent, if you have two of them, you use the prefixes to name them. Okay, but this is the only time you're going to use prefixes, is with covalent compounds. Okay, these are the easiest of all of them to do. All right, we'll have practice of those. All right, so now let's look at the third one. Acids. Okay, and we learned, I told you at the beginning, that acids all contain which ion? Hydrogen. Okay, H plus. We have the general formula HX, where H is the H plus attached to any anion. So I can take, if I put a hydrogen onto any one of these, I have acetic acid, hydrobromic acid, carbonic acid, HClO3 is chloric acid, and H in front of any one of these is going to make an acid. Now if it's a -2, it's going to take 2 H's. If it's a -3, it's going to take 3 H's. Because we always want it neutral. Hydrogen has a +1 charge. Okay? So all depending on stuff, if it's just a -1, I'll put 1 hydrogen on it. But all acids, hydrogen is the first thing. That's how we're going to recognize it. Okay? So since they all have the same positive thing, the name is dependent upon the negative thing. What are our 3 possible endings for an anion? Our anions end in what 3 suffixes? Ate, ite, and ide. Okay, so the suffix of our anion, since it's hydrogen plus any anion, what the anion ends in is going to determine the name. If the anion, okay, if the positive ion is hydrogen, that's just telling me it's an acid. If the hydrogen is attached to something that ends in ide, fluoride, chloride, bromide, sulfide, we're going to use hydro, root word, and then the ic suffix. Okay? So I'm going to look here. I want to name this. So the first thing I'm going to do is I'm going to look at the anion that the hydrogen is attached to. What's this? So Cl. What is the name and charge of Cl? The ion.
It's fluoride, so -1.
It's going to be -1, and it's going to be named what? Chloride. Okay, so Cl minus is equal to chloride. So HCl is going to equal root word hydro, and then the root word chlor, and then ic acid. Hydrochloric acid. So S2 minus is going to be called what?
Hydrosulfuric acid.
Well, just the name of the anion. You jumped ahead of me.
Okay, that's sulfide.
Sulfide. Okay. So again, it's ide. So H2S. Notice because it's -2, I need 2 hydrogens to make it the acid to balance it out because each hydrogen's +1. Okay. So now it's going to be what? Go ahead, Henry. Now what?
Hydrosulfuric acid.
Hydro. Okay. Now that is what I would expect you to say. But for some reason, sulfur and phosphorus, they keep the UR in there. And you're just going to get the feel of it. So it's sulfuric. Now, if you wrote hydrosulfuric acid, I would not mark it wrong. But for sulfur and phosphorus, they keep the UROR in there just for, I don't know, making it sound better. I don't know. Somebody decided that a long time ago. So it's sulfuric acid. So what's F minus going to be? Fluoride. So HF is going to be hydrofluoric acid. Hydrofluoric acid. Okay? Now, only, this is when it ends in "ide." Okay? Notice there's no oxygens in there. This is just a binary acid, it's not an oxyacid. Does everybody have all this copied down?
Yes, sir.
We good? Going once, going twice? Alright? Now, pay attention because on these next ones, everybody always wants to put hydro in here, but we're not going to put hydro. We're still going to be dependent upon the root word. If the anion ends in "ite," we're going to change it to "us." "Ite" goes to "us," and then "ate," we're just going to change it to "ick." Okay? No hydro. We're just taking the root word of the anion. "Ate" goes to "ick," and I always tell people, think about eating something in the cafeteria. If you ate something in the cafeteria, a lot of times you go "ick." "Ate" goes to "ick." Okay? "Ite" goes to "us." "Ate" goes to "ick." "Ite" goes to "us." So if I look at here, SO3 2- is the sulfite ion. Now since it's -2, to make it an acid, I have to be neutral, so I need 2 H pluses to balance it out. If that's a -1, I add 1 hydrogen. If it's -3, I add 3 hydrogens, okay, to make it neutral. So now it's going to be, just change this, but again, you put the UR back in there. So it's going to be, what? Sulfurous acid. Okay? So the "ite" goes to "us." "Ite" goes to "us." So now we have nitrite. So HNO2 is going to be what? Nitrous acid. Again, you have the "us," and so the "ite" goes to "us." Okay? But now down here, 8 goes to "ick." So if this is sulfate, what's H2SO4 going to be? Sulfuric acid. Again, the 8 goes to "ick." So this is the nitrate ion. Now again, you're going to have this ion sheet, so you don't have to memorize the name of these ions. You just got to take the time to look. You always look at what's the hydrogen attached to. Okay, in HNO3, well, the hydrogen is attached to the nitrate, so the name of HNO3 is going to be, say that again, nitric acid. Okay, again, "ick" and 8 go to each other. So we recognize it's an acid because the positive thing is hydrogen. We name it according to the suffix of the anion. "Ite," "ite," and 8. I'm going to give you a flow chart tomorrow that's going to have all of this all right on one page, all the rules on one page. All right, so we just got to turn the page and just go the other way. We got 5 minutes to do this. And then tomorrow we'll just practice. Okay, so now we want to just go the other way. Writing the formulas. Determine the formula charge of the anion. It's always the anion. And then we add enough hydrogen so the molecule's neutral. Again, if it's -1, we add 1. -2, we add 2. -3, we add 3. Because each hydrogen's +1. So, hydrofluoric acid. Hydro is going to tell me it's binary, which means it's fluoride. Hydro is going to tell me that this is from fluoride. Okay? So, what's the formula going to be? If it's only H and F. What's the charge on just fluoride? -1. I know that by position on the periodic table. So if this is -1, I only need one of these. It's just going to be HF. But now, phosphoric, there's no hydro. It's it, but there's no hydro. So that means that the anion is what?
8.
Okay, it's phosphate. Or what's the formula for phosphate?
PO4.
With what charge?
Minus.
3 minus, right? Or -3, doesn't matter which way you put it. 3 minus is technically the correct way. So how many hydrogens do you have to add to make it the acid? It's -3, so how many hydrogens do we have to put? 3. So what's the formula going to be?
H3PO4.
The H always goes first, so it's going to be H3PO4. And the chloris, okay, so ick came from 8 again. So chloris came from which anion? Chlorite. And you go and you look on your sheet and you find that chlorite is what formula? What's chlorite?
ClO2.
ClO2 with what charge?
-1.
-1, so how many hydrogens do I put on it to make it neutral? 1, and it always goes to the front, so then the formula of the acid is going to be HClO2. And I'm going to put it out here, you put it wherever. HClO2. That's all there is to it. Okay? So acids, all have the positive ion as hydrogen. So the name of the acid is always dependent upon the anion to which it's attached. Anions end in "ide," "ite," or "ate." So you're just going to have to remember this. So again, this is just going to take practice. Tomorrow I'm also going to, I'll give you a flow chart. I'm also going to introduce the project that is going to be due like in 2 weeks, which is going to be naming common household items. That's where you have the poster and you get the labels and things. And I'll detail that out for you. It's going to be an 80-point project. Okay, so it's going to be important. It's our last project of the year.
Does that mean you're making this test extra hard?
No, the test is actually 33 multiple choice questions. Okay? No short answers. It's all just I'm going to give you the name and give you 4 choices for the formula. I'm going to give you the formula, give you 4 choices for the name, and then there's going to be 2 or 3 where you have to determine the oxidation state. Okay? They should. If they study. All right. Well, y'all, good day today, and go Jags.